Okay.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We from Group 1. I'm Shira and my friend Haris Azril, Bentuk Sanjas, Ifah Ilyana and Nawfal Hafiz will together present and explain about this chapter. This chapter is about database system, design, implementation and management. Chapter 2, data models. Next. Firstly, objective about data modeling and why data model are important. Number 2, about the basic data modeling building block. Number 3, what business rules and how they influence database design. 4, how the major data model involved. And last one, how data model can be classified by level of abstraction. Next, introduction. Designer, programmer, and end user see data in different way. Number 2, different view of same data lead to design that do not reflect organization operation. Number 3, data modeling reduce complexity of database design. And last one, various degree of data extraction help reconcile varying views of same data. Next, data modeling and data models. What is data model? Relatively simple representation of complex real-world data structure, often graphical. Model and abstraction of a real-world object or event are useful in understanding complexity of the real-world environment. The last one, data modeling, is interactive and progressive. Data modeling also facilitated interaction among the designer, the application programmer, and the end user. Next, I will pass to Haris Hazri.
Okay, the next one is I will explain about the importance of data models. Number one is facilitate interaction among the designer, the application programmer, and the end user. And second one is end user have different views and needs for data. Number three is data model organize data for various user. And the last one is data model is an abstraction. Cannot draw required data out of the data model. The next one is data model basic building blocks. Number one is entity, anything about which data are to be collected and stored. And the second one is attribute, characteristic of an entity. And number three is relationship, describes an association among entities. One to many, 1M relationships, many to many, MN or MM relationship, one to one is relationship. And the constraint is a restriction placed on the data.
I explain this. This is an example of a data model. This is an entity and this is an entity. In the middle there will be a relationship, as you will see later in the below. 1, 2, and 3 here will be an attribute. like it said here, entity is pelajar pensyarah kursus fakulty and program. There is 5 entity right here. And in the middle of them, there's a relationship between them, which means pelajar ambil kursus, pensyarah ajar pelajar, and more like that. This M represents the relation, the one to many. This is M to M, so it's many to many, and so on. I will pass this to our friend Ifailana.
Okay, next, business rules. Of policies are procedure or principle within a specific organization apply to any organization and use description of operation to create or enforce action within an organization environment, and then must be in writing and kept up to date. Next, must be easy to understand and widely disseminated and describe characteristics of data as viewed by the company. Next. Discovering business rules. Source of business rules. Company managers, policy makers, department managers, written documentation, procedure standard, operation manuals, and direct interview with end users. Next, discovering business rules. Standardized company view of data, communication tool between users and designers, allow designer to understand the nature, role, and scope of data, allow designer to understand business process, allow designer to develop appropriate relationship participation rules and constraints. Next, translating business rules into data model component. Generally, nouns translate into entities, verbs translate into relationship among entities. Relationships are bidirectional. Then 2 questions to identify the relationship type. How many instances of B are related to one instance of A? And how many instances of A are related to one instance of B?
Okay, thank you, Ifa. I'll take it from here.
Okay.
Now we look at the evolution of data models. In the first generation, the timeline is 1960s to 1970s, and the model is file system, which is an example of VMS and VSAM, which is virtual storage access method. They are used mainly on IBM mainframe systems, and they are used to manage records but not relationship. In the second generation, which is the timeline in 1970s, their model is hierarchical and network data models, which is IMS, ADABAS, and IDS2. IMS is Information Management System, and IDS is Integrated Data Store, and they're used in early database systems and navigational access. The third generation is mid-1970s to present, which is now. Their model is relational data models, and the examples is DB2, Database2, Oracle, Microsoft SQL Server, and MySQL. They are conceptual simplicity. They have entity relationship modeling and support for relational data modeling. And fourth generation, which is mid-1980s to present, which is also now. The model is object-oriented and extended relational. For the example is Versant, FastObject.net, Objectivity, DB2, Oracle 10G. They support complex data, extended relational products, supports objects and data warehousing. Web databases became common thanks to this. And the next generation, which is now, and possibly to the future, their model is XML. Examples of that is DB XML, Terminal, DB2, Oracle 10G, and MS SQL Server, which is Microsoft. The comments is organization and management of unstructured data, relational and object models add support for XML documents. This hierarchical model is developed in the 1960s, as we see just now, to manage large amounts of data for manufacturing projects. Basic logical structure is represented by an upside-down tree, which you will see later in a later slide. Their hierarchical structure contains level or segments, and each segment is analogous to a record type, set of one-to-many relationship between segments. This is an example, and it is said to be that every first one is a parent, and this one is a child, which is basically their children. So this is a parent, this is a children, this is a parent, this is a children. And each segment is analogous to each other. Basically, they are related somehow. And I'll pass this on to my friend Naufal.
Hello. Okay. Hi, thank you, Venkat. I'll take it from here. So this chapter is about the hierarchy model, which is for the previous model that we just saw, figure 2.1. So this foundation is the current. This foundation is the current data foundation for the current data models. The model that the structure that we just saw just now is the current model that we use today until today. So there are a couple of disadvantages of the hierarchical model, which is complex to implement, is difficult to manage, it lacks of structural independence, relationships do not conform to one-to-many form, no standards for how to implement. So it's kind of hard to, I mean, let's say I would say that it needs a lot of studies to have a successful hierarchical model structure. Next, for the network models, so it is created to represent a complex data relationship more efficiently. It improves the database performance and also imposes a database standards. So conference on data system languages created the DBTG, which is a database task group. The database task group is defined environment to facilitate database creation. And the data module also comes in a couple of sets, a couple of things in it, such as schema, which is a conceptual organization of entire database as viewed by the database administrator. Subschema, which is database portion seen by the application programs. Data management language, DML, defines the environment in which data can be managed. Next. So the network model resembles a hierarchical model, which record may have been more than one parent. It collects of records in one-to-many relationships. A set composed of two record types, which is the owner and the member. Owner is equivalent to the hierarchical model's parent. The member is equivalent to the hierarchical model's child. So so that's our group's present for today for this chapter until 18th page. I will let the rest to be on the second group too. Thank you.
So my group is the next. Okay.
Okay, thank you guys for the first group. Before the second group start presenting, I just have few comments on the presentation. I noticed that the ladies in the group, when they present, they are a bit shy. So please whenever you are trying to present or anything, don't be shy. Try to read the slide beforehand. Try to prepare. So this will be something, inshallah, you can work on and you can, inshallah, improve. And also, I couldn't help but notice that most of the group members are reading from the slide. Okay, I know, guys, that you are reading from the slide. So, but it will be better for you sometimes to try and get examples outside the slide. Try to explain it in your own words. It's up to you. But this is just like a minor comment. And these are the two main things. Other than that, everything was okay. And thank you. The second group can go.
Okay, Doctor. Everyone can see my screen now?
Yes.
Okay.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today we are going to continue present about database system, design, implementation and management. Next. So this is our group member. Next. So this is an example of network model for a finance department. So in a network model, a one-to-many relationship has a link between two record types. Now, in the above figure, salesman, customer, product, invoice, payment, and invoice line are the type of records for the sales of a company. Now, as you can see in the given figure, invoice line is owned by product and invoice. Invoice has also two owners, salesman and customer. Next. The disadvantages of the network model is cumbersome. The second one is lack of a hard query capability place burden on programmers to generate code for reports. And the third one is structural change in database code produce havoc in all application programs. Next. The relational model is developed by E.F. Code IBM in 1970. After designing the conceptual model of database using ER diagram, we need to convert the conceptual model in the relational model, which can be implemented using any RDMBS language. So relational models considered in practical in 1970. Models conceptual is simple at expense of computer overhead. Next. Relational Data Management System is RDBMS is performs same functions provided by hierarchical model, hides complexity from the user. Relational diagram is representation of entities, attributes, and relationships. Relational table store collection on related entities. Next. So this is the example of relational table. Next. And this is the relational diagram. Next. SQL is based relational database application involves three parts. The first one is user interface, allow end user to interact with the data. The second one is set of tables stored in the database. Each table is independent from another. Rows is different table related based on common values in common attributes. The third one is SQL engine. Execute all queries. Next.
Next is the entity relationship model. Entity relationship model widely accepted standard for data modeling. This model introduced by Chen in 1976. The entity relationship model graphical representation of entities and their relationship in a database structure. Entity relationship diagram or ERD uses graphic representation to model database components. Entity is mapped to a relational table. Next. Entity instance or occurrence is row in table. Entity set is collection of like entities. Connectivity labels type of relationship. Relationship expressed using chain notation. Relationship is presented by a diamond. Relationship name written inside the diamond. Crossfoot notation used as design standard in this book. Next. Okay, this is the chain and crossfoot notation. The first one is a one-to-many relationship. So, one painter can paint many paintings. Next is many-to-many relationship. An employee can learn many skills. The last one is one-to-one relationship. An employee manage one store. Next.
Okay, next we are going to the object-oriented model. Object-oriented model is a data and relationship contained in single structure known as an object. OODM, Object-Oriented Data Model, is the basic for OODBMS, Semantic Data Model. Object contain operation. Object is self-contained, a basic building block for autonomous structures. Object is an abstraction of a real-world entity. Next. The object-oriented model continued. Attributes describe the properties of an object. Object that share similar characteristics are grouped in class. Classes are organized in a class hierarchy. Inheritance object inherits method and attribute of parent class. UML based on OO concept that describe diagram and symbol. User to graphically model and model a system. Next, this is a comparison of OO, UML, and ER model. So you guys can see the figure. Okay, next.
Next, the converse of data models. A standard relational data model, ERDM, semantic data model developed in response to increasing complexity of application, includes many of OO models' best features, often described as an object or relational database management system, or RDBMS, primarily geared to business application. Next. Database models and the internet. Internet drastically changed role and scope of database market. Focus on internet marks underlying data model is important. Dominance of web has resulted in growing need to manage unstructured information. Current database support XML. XML is the standard protocol for data exchange among system and internet service. Next. Figure 2.7 is the development of data models. Hierarchy and where this comment is difficult to represent M and relationship. This is for hierarchy only. Structure level dependency, no ad hoc queries, and access per defined. For relational, comment is conceptual simplicity, provides ad hoc queries and set-oriented access. For entity relationship, easy to understand and limited to conceptual modeling. For semantic, has two, which is object-oriented and extended relational. More semantic in data model, support for complex object, inheritance, behavior, and structured data XML. XML is data exchange. Next. This is a summary for data models. Common characteristic. Conceptual simplicity with semantic completeness. Represent the real world as closely as possible. Real world transformation must compete with consistency and integrity characteristics. Each new model, each new data model capitalizes on the shortcomings of previous models. Current models be better suited for some tests. Next. This is a data model basic terminology comparison, so you guys can see this table. And then that's all from our group. Thank you.
Thank you, guys. For the next group, they can proceed.
Thank you, Doctor. Thank you, everyone.
Good evening, everyone. We are from Group 3. Next is degrees of data abstraction. First of all, database designer starts with abstracted view. Then only they will add details. And ANSI, Standards Planning and Requirements Committee, SPARC, they define a framework for data modeling based on degrees of data abstraction on 1970s. Those are external model, conceptual model, and internal model. Okay, let's see the external model. External model is end user's view of the data environment. ER diagram means entity relationship diagram. Entity relationship diagrams represent external views, and the external schema is specific representation of an external view. Those consist of entities, relationships, processes, and constraints. Let's see figure 2.8, data abstraction level. Let's see from the lowest layer to higher level. Let's see the external model. External model is end user's view, and it goes to conceptual model. Conceptual model is designer's view, and it goes to internal model. Internal model is database management system's view, and in between they use the logical independence. And from internal model they goes to physical model. In between they use physical independence. Okay, let's see the table beside that. Degrees of abstraction and characteristics. Let's see the high ER and object-oriented. Its characteristic is hardware independent and software independent. And next layer is medium and relational. Its characteristic is hardware independent and software dependent. And lowest layer is low network and hierarchical. And its characteristic is hardware dependent and software dependent.
Next, the external model easy to identify specific data required to support each business unit operation. The next, the facilities designer's job by providing feedback about the model adequacy. The external model also ensure the security constraint in database design. Then the external model is simplifies application program development. Next, this figure show the another external model for tiny college with the kiri student registration. Student may take up to 6 classes per registration. Then the student enrolls in some subject taken by classes and generate the cost. After that, class scheduling. A room may be used to teach many classes, used for class. Then the class being taught by the professor. Then the class also generate the cost. Next. These are related with the chance and chow food notation, which the relationship student and enroll is a one-to-many relationship. A student can enroll many of subject. Then the enroll with the class is many to one relationship with one enroll manage one class. Each class managed by one enroll. Also, the class is many to one relationship.
The conceptual model. It represents global view of the entire database. All external views integrated into single global view conceptual schema. ER model most widely used. ERD graphically represents the conceptual schema. Next. Once students enrolls in many enroll.
Excuse me, guys.
Yes.
Hello, guys.
Yes, Doctor.
Yes, Doctor.
Yeah, I have to go for 5 minutes. Can you stop for 5 minutes and we can resume? Can we take 5 minute break?
Yes. Okay.
Okay, thank you.
Thank you, Doctor.
Guys, Assalamu alaikum. Please proceed to the presentation.
The next one is Conceptual Model for Tiny College. One student enrolls in many enroll. Menu enroll is taken by one class. One professor teach many class. Many class is used for one room. And lastly, many class generates one course. Next. The conceptual model continued. It provides a relatively easily understood macro-level view of data environment. It independent of both software and hardware. It does not depend on the DBMS software used to implement the model, does not depend on the hardware used in the implementation of the model. Lastly, it changes in hardware or software do not affect database design at the conceptual level. Next.
The internal model. The internal model is the representation of the database as seen by the DBMS. It maps the conceptual model to the DBMS. Internal schema depicts a specific representation of an internal model, depends on specific database software. Change in DBMS software require internal model can be changed. Logical independence change internal model without affecting conceptual model. The example of an internal model. Conceptual model start with professor. The internal model is create table professor, prof ID, number primary key, prof last name, char, prof initial, prof F name, and then number primary key, char 15, char 1, and char 15. And this class, read table, class ID, CRS ID, prof ID, room ID, number primary key, char 8, reference course, number reference professor, char 8, reference room, and then issues for room, create table room ID, room type, char 8, primary key, char 3.
and generates cost, create table cost, CRS ID, CRS name, CRS credits, char 8 primary key, char 35 numbers. Next. The physical model operates at lowest level of abstraction, describe the way the data are saved on storage media such as disk or tapes, requires the definition of physical storage and data access models. Relational model aimed at logical level does not require physical level details. Physical independence changes in physical model do not affect internal model. Next. Example of levels of data abstraction, model external, degree of abstraction, focus and independence of external. Degree of abstraction is high, focus is end user views and independent of hardware and software. Conceptual is in between high and low. Focus on global view of data, database model independent and independent of hardware and software. Internal in between high and low. Focus on specific database model and independent of hardware. Physical is low and focus on storage and access model. Methods independent of neither hardware or nor software. Okay, next. So the summary of the chapter is a data model is an abstraction of a complex real-world data environment, and basic data model ni components such as entity, attribute, relationship, and constraint. Business rule identify and define basic model component. Next. Hierarchical model is a set of one-to-many relationship between a parent and its student segment. For the network data model is used set to represent one-to-many relationship between record type. Relational model is a current database implementation standard, and ER model is a tool for data modeling, such as component relational model. Next. Object-oriented data model is a basic modeling structure, and relational model adopted object-oriented extension is extended relational data model that called ERDM. OO data model is depicted using UML, and lastly, data modeling requirements are a function of different data view and abstraction level. Three abstraction level such as external, conceptual, and internal. Okay, that's all from me all. Thank you.
Hello, we are from Group 4 and today we are going to present Chapter 3. So, Chapter 3 is about the relational database model, and maybe next. Maybe. Oh, okay. Okay. Objective. In this chapter, that we will learn about that the relational database model offer a logical view of data, about the relational model basic component relation. That relation are logical construct composed of row, tuples, and columns attributes. That relation are implemented as table in a relational DBMS. Next. This furthermore about objective, about relational database operator, the data dictionary, and the system catalog. How data redundancy is handled in the relational database model and why indexing is important. And next. A logical view of data, a relational model, view data logically rather than physically. For table, a structural and data independence resembles a file conceptual, and relational database model easier to understand than hierarchical and network model. Okay, next. Table and their characteristic. Logical view of relational database based on relation. Relation thought of as a table. Table, two-dimensional structure composed of row and columns. Persistent representation of logical and relation. Contain group of related entities and entity set. Okay, next I will pass to Yishuan.
Okay, next, the characteristics of a relational table. First, a table is perceived as a two-dimensional structure composed of rows and columns. Each table row tuple represents a single entity occurrence within the entity set. Each table column represents an attribute, and each column has a distinct name. Number 4, each row column intersection represents a single data value. Number 5, all values in a column must conform to the same data format. Number 6, each column has a specific range of values known as the attribute domain. Number 7, the order of the rows and columns is immaterial to the DBMS. The last one, each table must have an attribute or a combination of attributes that uniquely and that identifies each row. Next. This is an example of student table attribute values. You can see the table contains the data, credits hour earned, student classification, student date of birth, breakpoint average, 4-digit campus phone extension, and number of the professor who is the student advisor. Next. The keys. Each row in a table must be uniquely identifiable. A key is one or more attributes that determine other attributes. Each row is based on determination. If you know the value of attribute A, you can determine the value of attribute B. Functional dependence. Attribute B functionally dependent on A if all rows in table that agree in value for A also agree in value for B. Next. Okay, the student classification. If hours completed less than 30 hours, the classification is FR. If 30 hours to 59 hours, the classification is SO. And 60 to 89 hours, the classification is JR. And 90 or more hours, classification is SR. Next, I will pass to Ruby.
The keys continued. Composite key composed of more than one attribute. Key attribute, any attribute that is part of a key. Next, super key, any key that uniquely identifies each row. The last one, candidate key, a super key without unnecessary attributes. The next one would be nulls. No data entry not permitted in primary key should be avoided in other attributes. Can represent an unknown attribute value, a known but missing attribute value, a not applicable condition. Continued can create problems when functions such as count, average, and sum are used, can create logical problems when relational tables are linked. Next would be controlled redundancy, makes the relational database work. Tables within the database share common attributes, enables tables to be linked together. Multiple occurrences of values not redundant when required to make the relationship work. Redundancy exists only when there is unnecessary duplication of attribute values. Next, I would like to pass to Satis.
Thank you, Ruby. Figure 3.2 is an example of a simple relational database. The table is named product and its primary key is product code and the foreign key in this table is vendor code. This foreign key will be linked between this table and another table. This table is being product table and the other one is vendor table. The foreign key in the table is also the primary key in vendor table, while vendor table does not have a foreign key. Figure 3.3. The relational diagram for the CH03_SailCO database. This allows a link to be formed between this table and it has a relationship of one-to-many. Keys. Foreign key, an attribute whose values match primary key values in the relatable table. Referential integrity. Fk contains a value that refers to an existing valid tuple row in another relation. Secondary key. Key used strictly for data retrieval purposes. Table 3.3. Relational database key. First key is super key, an attribute for combination of attributes that uniquely identifies each row in a table. The next key is candidate key, a minimal irreducible superkey, a superkey that does not contain a subset of attributes that is itself a superkey. The third one is primary key, a candidate key selected to uniquely identify all other attributes value in any given row and cannot contain null entries. Secondary key, an attribute or combination of attributes used strictly for data retrieval purposes. The last one is foreign key, an attribute or combination of attributes in one table whose values must either match the primary key in another table or being null. Table 3.4, integrity rules. Entity integrity, the requirement. All primary keys entries are unique and no part of a primary key may be null. The purpose, each row will have a unique identity and foreign key values can properly reference primary key values. For example, no invoice can have a duplicate number, nor can it be null. In short, and all invoices are uniquely identified by their invoice number. Referential integrity. The requirement. A foreign key may have either a null entry as long as it is not a part of its table primary key, or an entry that matches the primary key value in a table to which it is related. Every non-null foreign key value must reference an existing primary key value. The purpose. It is possible for an attribute not to have a corresponding value, but it will be impossible to have an invalid entry. The enforcement of the referential integrity rules make it impossible to delete a row in one table whose primary key has mandatory matching foreign key values in another table. For example, a customer might not yet have an assigned sales representative number, but it will be impossible to have an invalid sales representative number. Thank you. We'll pass it to the next group.
Assalamualaikum. We are from group 5. So this is our member. This is an example of an illustration of integrity rules. Next. Integrity rules are needed to inform the DBMS about certain constraints in the real world. Specific integrity rules apply to one specific database. For example, part weights must be greater than 0. General integrity rules apply to all databases. Many RDBMS enforce integrity rules automatically. It is safer to ensure application design conforms to entity and referential integrity rules. Designers use flags to avoid nulls. Flags indicate absence of some value. Next. Relation set operators are used to combine or subtract the records from two tables. These operators are used in the select query to combine the records or remove the records. Define relation algebra also define theoretical way of manipulating table contents using relation operators. It is use of relation algebra operators on existing relations produce new relation. Union, intersect, different product, and select project join divide. Next. Union combines two different results obtained by a query into a single result in the form of a table. However, the result should be similar if union is to be applied on them. Union removes all duplicates, if any, from the data and only display distinct value. If duplicate values are required in the resultant data, then union all is used. This is an example of union. Next.
This is for intersection. For intersection, as example, you can see here, there are two columns, and when intersect, we will compare the two of them, and which is the similarity will become the yield for the intersection. For the difference, there are two types of full names, and when the difference, the one in it was just the opposite of the intersection, the one that there were no similarity between them. For example, here, the difference, the yields are George, Elaine, and Wilfried. Next, for products, For products, they are different in rows. So you just add on this side of the table. We just combine both of them because they are from different categories. So we add them horizontally. Next, I will pass to Anik.
Okay, this is the select table.
Damn.
It select the P code from the original table, and you can use it to the new table. And then you can select the
Oh my
price
god,
and use it to the new table also. You also can select the P code and put it in the new table. Next. Next, please. Hello. Okay, now this is the algebra operators that based on select, project, join, divide. In the upper left table, we got an original relational table that have three contents that are P code, P description, and price. We can divide this content from the original relational table to create a new relational table as shown of the upper right table that use the content of the original table, which divide the price and use it to build a new relational table. The same can be done to the second table that took the P description and price from the original table to create a new relational table. And the third table which use P code and price to create a new relational table. Next. So this is two tables that will be used in joining illustration. The first table is named customer with the contents of cus code, cus L name, cus zip, and agent code, while the other is named agent with the content agent code and agent phone. Next. Relation set operators. First is natural join. Link tables by selecting rows with common values and common attribute. Second is equijoin. Link tables on the basis of an equality condition that compares specified columns. Third is theta join. Any other comparison operator is used. And lastly is outer join. Match pairs retain and any unmatched value in other table left null. That's from me. I will pass it to Mashni.
This table shows the left outer join table. This table contains customer code, customer name, customer zip, agent code, and agent phone. Next. Well, this table shows the right outer join. This table contains customer code, customer name, customer zip, agent code, and agent phone. Next. And this figure shows how the table divides. Next.
Data Dictionary and System Catalog. Data Dictionary provided detailed accounting of all tables found within the user or designer-created database. Data Dictionary contains metadata, where data provides information about other data. System Catalog contains metadata, which consists of tables and views that describe the structure of the database. Next. A sample data dictionary consists of table name, attribute name, contents, type, format, range, required, primary keys or foreign keys, and foreign keys reference table. Next. There are three types of relationship within the relational database. First, On-to-many relationship. In on-to-many relationship, one record in a table can be associated with one or many records in another table. For example, each customer can have many sales orders. On-to-one relationship. In on-to-one relationship, one record in a table associated with one and only record in another table. For example, in a school database, each student has only one student ID, and each student ID is assigned to only one person. Many-to-many relationship. A many-to-many relationship occurs when multiple records in a table are associated with multiple records in another table. For example, a many-to-many relationship exists between customers and product. Customers can purchase various products, and product can be purchased by many customers. That's all from our group. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening. So we from group 6 will continue the presentation. So the one-to-m relationship or one-to-many relationship. One-to-many relationship is a relational database norm found in any database environment. So figure 3.18 shows the example for one-to-many relationship between painter and painting. As you can see, painter can paint more than one painting, but the painting only can be painted by one painter. Okay, next. Okay, figure 3.19 is another example. As you can see, painting number 1338 and 1339 have the same painter number, which is 123. It means that the painting is be painted by the same painter. Okay, next. Okay, we move on to the one-to-one relationship. One-to-one relationship is one entity related to only one other entity and vice versa. Sometimes means that entity components were not defined properly, could indicate that two entities actually belong in the same table. Certain conditions absolutely require their use. Next. Okay, this is an example for one-to-one relationship between professor and department. So the professor only have one chair in the department. Okay, so we will move on to Hafizuddin.
Next. The M-to-N relationship. First, implemented by breaking it up to produce a set of 1-to-M relationship. Second, avoid problem inherent to M-to-N relationship by creating a composite entity. Include as foreign keys the primary keys of tables to be linked. Next. Figure 3.24. This is how the M-to-N relationship between student and class. Next. Atas sikit. Figure 3.26. Convert the M-to-N relationship into two 1-to-M relationship. Table name, student, primary key, stu_num, foreign key, none. Table name, enroll, primary key class underscore code plus stu underscore num. Foreign key class underscore code stu underscore num. Table name class primary key class underscore code foreign key crs underscore code. Next. Figure 3.27. Changing the M to N relationship to 1 to M relationship. This is example. Next, I will pass to Daniel.
Thank you, Hafiz. Alright, next is the expanded entity relationship model. So you guys can see the 4 section start from student, and you must be registered and enroll and show in the class, and the last one you guys has the course. Next. Alright, next is the relational diagram for the chapter 3, tiny college database. So each section has a list of the data. Student, we have I think 12 data. So next to the going to the second section, which is the enroll. So we have a class underscore code, and second is stu underscore num and enroll underscore grade. So we jump to the third section, which is a class. Class underscore code, CRS underscore code, class underscore section, class underscore time, class underscore room, and the last one is a prop underscore num. So the last one, we're going to the last section, which is a course. So CRS underscore code, DEPT underscore code, CRS description, and the last one is a CRS underscore credit. Next. So data redundancy revisited. Data redundancy leads to data anomalies. Such anomalies can destroy the effectiveness of the database. Foreign keys. Control data redundancies by using common attributes shared by tables. Second is crucial to exercising data redundancy control. So the last one is sometimes data redundancy is necessary. I think before we create any of the data, we need to first check the data that we create before, so that the data is more organized and the data is in a safe state. All right, thank you. I will pass to Rashida.
Alright, thank you, Daniel. Now I want to present about the relation diagram for the invoicing system. Create customer invoice with no code needed. Send invoice in minutes and get paid faster. Capture all your payment to easy to use automated invoicing that have example customer related with invoice, related with line, related with product. Next, index. Orderly arrangement to logical access row in a table. Index key. First index reference point, second point to data location identified by the key. Units index. Index in which the index key can have only one pointer value row associated with it. Each index is associated with only one table. Next, component of an index. Painting table index that have painter num, index key, second pointer to the painting table row. The number of share of the index component will be rounded to 6 decimal place. An index is made up of several parts: a main heading, subheading, locator, and cross-reference. A main heading is always a noun, noun phrase, or a gerund. Next, I will pass to Hazira.
Okay, next slide is called relational database rules. In 1985, Code published a list of 12 rules to define a relational database system. Product marketed as relational that did not meet minimum relational standards. Even dominant database windows do not fully support all 12 rules. Next, The summary is tables are basic building blocks of a relational database. Keys are central to the use of relational tables. Keys define functional dependencies, superkey, candidate key, primary key, secondary key, forward key. And next summary, each table must have a primary key that uniquely identifies all attributes. Table links by common attributes. The relational model support relational algebra function is select, project, join, intersect, union, difference, product, and divided. Good design begins by identifying interdicts, attributes, and relationships. 1 ratio 1, 1 ratio m, m ratio n. And that's all from we all.
Hello. Okay, guys. Thank you for all your presentations. I think, alhamdulillah, it went smooth. But I think there were so many informations in which were extra and so many reading from the slides. So, inshallah, for the next chapter, which will be chapter, if I'm not mistaken, 4 or 5, I will give you the slide today so you can prepare it the same way. And inshallah, for these two chapters, inshallah, next week when we start at 3 p.m. or 2:30, we will give the first 40 or 30 minutes. I will do the revision with you, and I will just touch on the most important topics within these two chapters and what is expected from these chapters that you will learn, whether now, in your midterm, in your final assessment, and for the rest of the course. Okay?
Okay, Doctor.
Thank you guys so much for today. And inshallah, for the next week, I want you to improve more. I want you to get from outside sources. You can bring videos to explain your point. You can use visual aid. And at the same time, I want you to be more flexible with the presentation. I don't want you to be shy. That's why we are practicing from now. So inshallah, we're going to improve. And inshallah, we're going to carry on with the rest of the chapters. Thank you so much.
Thank you, Doctor.
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 Thank you, Doctor. Thank you, Doctor.